Ever wished you could organize your Python code like a pro, reuse awesome functions you've written, and tap into a universe of pre-built tools without having to write them yourself? Today, we're doing just that. We're unlocking your code's superpowers with Python modules and import. By the end of this video, you'll understand what modules are, how to create your own, and how to use the mighty import statement to bring external code into your projects. Get ready to write cleaner, more efficient Python. So what exactly are modules? Simply put, a Python module is just a Py file that contains Python code. This code can be functions, classes, or even just variables. Think of it like this. Imagine you're building with Legos. Each Lego brick has a specific shape and purpose, right? A Python module is like one of these individual Lego bricks. You can build a function in one brick, a variable in another, and then snap them together to build something much bigger and more complex, like a cool spaceship or a castle. What are the big benefits of using modules? First, code organization. Instead of one giant messy file, you can break your code into smaller, manageable pieces. Second, reusability. Write a useful function once, save it in a module, and then use it in any of your projects. And third, it helps avoid naming conflicts. If two different parts of your code use the same variable name, modules help keep them separate. Now let's talk about the import statement. This is your gateway to reusing code. The most basic way to use it is import module name. This brings the whole module into your current script. Import math. Print math.py, output 3, 1415926535897993. Sometimes, module names can be a bit long. That's where import module name as alias comes in handy. You give the module a shorter, more convenient name. Import random as rnd, print rn randint 110, output a random integer between 1 and 10. What if you only need a specific function or variable from a module? You can use from module name import specific item. This avoids bringing in the entire module, keeping your workspace cleaner. From math import py. Print py, output 3, 1415926535897993. There's also from module name import str. This brings everything from the module directly into your script. While it seems convenient, be cautious. It can lead to naming conflicts if you have functions or variables with the same names in your current script and the imported module. We generally advise against using import str in larger projects. Example of where star can be tricky. In module A py, my var equals 10. In module B py, my var equals 20. If you do, from module A import star. From module B import star. Print my var, which my var would it be? It's unpredictable and error prone. Python also comes with many powerful built-in modules. You don't need to install them, they're ready to use. For instance, the math module gives you mathematical functions like square roots and pi. The random module helps you generate random numbers, perfect for games. Import math. Print math sqrt16, output 4.0. Import random. Print random.choice apple, banana, cherry, output a random fruit. All right, enough theory. Let's get our hands dirty and write some code to see this in action. First, let's create our own module. I'm going to open my code editor. I'll create a new file and name it myutils.py. Def greet name, return f hello name. Def add ab, return a plus b. Here I've created two simple functions, greet, which takes a name and returns a greeting, and add, which sums two numbers. Crucially, I'm saving this file as my utils. Common mistake alert. If you forget to save your file or save it in a different folder, Python won't be able to find it when you try to import it. Solution: always make sure your module file is saved in the same directory as the script you're trying to import it into, or that its location is added to Python's path. For now, keeping them in the same folder is the easiest way. Now let's create a separate file, say mainscript py, to import and use our new module, mainscript.py. Import myutils. Print myutils.greet Alice. Result equals myutils. Add 10, 5. Print the sum is result. See how we use myutils.greet and myutilsadd? We're calling the functions by first typing the module name, then a dot, then the function name. Let's run this. Perfect. Now let's try importing with an alias. We can make myutils shorter, maybe mu. Main script pi, import myutils as mu. Print mu, greet Bob, result equals mu. Add 27. Print the new sum is result. Running this, we get the same great results, but with less typing. What if we only want the greet function and nothing else? We can use selective importing. Main script pi, from myutils import greet. From myutils import add, you can import multiple specific items. Print greet Charlie. Print add 82. Notice now we can call greet directly without myutils in front of it. Next, let's quickly see some built-in modules. We'll use math and random. Built-in example pi, import math. Print the value of pi is math pi. Print square root of 64 is math sqrt 64. Import random. Random number equals random. Randinct 1, 100. Print a random number between 1 and 100. Random number. When you run this, Python already knows where to find math and random, and you get instant access to their functions. Troubleshooting tip. You might sometimes see a module not found error. This means Python can't find the module you're trying to import. Most of the time, it's a typo in the module name or the file isn't in the correct directory. Double check your spelling and file location. Great job on the hands-on section. Now let's apply what we've learned to a practical mini project. For our project, we're going to build a simple math helper using modules. Our goal is to create a module named Math Operations that will hold functions for basic math operations. Then we'll create a main calculator that uses these functions. Let's start by creating math operations. Mathoperations.py. Def add xy, return x plus y. Def subtract xy, return x minus y. Def multiply xy, return x times y. Def divide xy. If y equals 0, return error cannot divide by 0. Return x divided by y. Here we have functions for add, subtract, multiply, and divide. I've also added a small check for division by 0 to prevent errors. Now let's create our main calculator script, maincalculator.py. Import math operations. Def run calculator, print welcome to the simple Python calculator. While true, print select operation. Print 1 add. Print 2 subtract. Print 3 multiply. Print 4 divide. Print 5 exit. Choice equals input. Enter choice 1, 2, 3, 4, 5. If choice equals 5, print exiting calculator. Goodbye. Break. If choice in 1, 2, 3, 4, try. Num1 equals float. Input enter first number. Num2 equals float. Input enter second number. Accept value error. Print invalid input. Please enter numbers only. Continue. If choice equals 1, print num1 plus num2 equals math operations. Add num1, num2. Elif choice equals 2, print f num1 minus num2 equals math operations subtract num1, num2. Elif choice equals 3, print f num1 times num2 equals math operations multiply num1, num2. Elif choice equals 4, result equals math operations divide num1, num2. Print f num1 divided by num2 equals result. Else, print invalid input. Please enter a number between 1 and 5. If name equals main, run calculator. In this script, we first import math operations. Then our run calculator function takes user input for numbers and the desired operation. We then call the appropriate function from our math operations module. Notice how clean maincalculator.py looks because all the actual math logic is neatly tucked away in math operations. Let's run this simple calculator. This demonstrates how logically separating different functionalities into their own modules makes your main script cleaner, easier to understand, and much simpler to manage or update later. You've done great so far. Now, it's time for a coding challenge to solidify your understanding. Your challenge: create a module called conversions that includes functions to convert Celsius to Fahrenheit, kilometers to miles. Then, in a separate script, import and use these functions to perform a conversion based on user input. Hint, remember the formulas. For Celsius to Fahrenheit, it's Celsius times 9 divided by 5 plus 32. For kilometers to miles, it's kilometers times 0, 621371. Ready for more? Let's talk about further exploration. You've learned about built-in modules and creating your own, but there's a vast world of external modules created by other developers. To install these, you use a tool called pip, the Python package installer. Pip lets you get amazing libraries like requests for making web requests or NumPy for powerful numerical operations. We'll cover pip in more detail in future videos, but it's good to know it exists. Finally, for larger projects, you might see something called packages. Packages are simply directories that contain multiple modules, often with a special init py file inside. It's just another way Python helps you organize really big code bases. Fantastic work today. Let's quickly recap the key takeaways. Modules are .py files for organizing and reusing your code. The import statement is how you bring modules and their contents into your scripts. We saw different import variations like import module as alias, and from module import specific item. And remember, modules make your code cleaner, more modular, and incredibly powerful. All the code snippets, the challenge, a quiz to test your knowledge, and these key takeaways are available in the video description below. Make sure to check them out. Now that you've mastered modules, you're ready to build something awesome. In our next video, we'll put these skills to the test as we dive into a simple Python project like a number guessing game. Don't miss it. Like the video, subscribe, and hit that notification bell so you don't miss our next lesson. See you there.